Hello everyone, hope all of you are doing great. And in today's video, we are going to discuss lesson 9.2, which is all about using the nth term. All right. So over here in the first question, they're saying to you, we're going to start from question 5. And they're saying to you over here, work out the first three terms and the 10th term of the sequences with the given nth term. So they need you to work out the first three terms. I'm going to remove n and write 1. So it is 8 times 1. 8 times 1 is 8 plus 7 is going to be 15. This is the first term. And the second term is going to be 8 times 2, which is 16, plus 7 is going to be 23. Then the third term is going to become 8 times 3, which is 24. 24 plus 7 is going to become 31. This is going to be the first three terms. So you need to write in the beginning over here, first three terms. Then down there, but because I do not have space over here, I'm thinking of opening a Word document. I'm going to open a Word document. But here, for now, for this question, the 10th term is going to be 8 times 10 is 80. 80 plus 7 is going to become 87. And this is going to be the nth term. All right. I will open a Word document just to have enough space. All right. And now we're going to work this out. Let's get this smaller. All right. So here, in the second example, which is 7n minus 8, what are we going to do? I'm going to multiply the 7 by 1 to get the first term. So 7 times 1. Then you minus 8 equals what? 7 times 1 is 7 minus 8 is going to become negative 1. So the first term here, I'm going to write that the first term, first three terms, negative 1. Then 7 times 2 is 14. 14 minus 8 is going to become 6. Then 7 times 3 is 21. 21 minus 8 is going to become 13. The 10th term is going to be 7 times 10 is 70 minus 8 is going to become 62. Next, they said half n minus 4. The first three, term 1 is going to be half times 1, which is half. Minus 4 is negative 3.5. Half times 1, here, as if you're saying half times 1. Then minus 4. Half times 1 is just half. What is half minus 4? Well, I'm going to subtract, so it's going to give me 3.5. But the sign of the bigger number is negative, so negative 3.5. The second term, half of 2 is 1. 1 minus 4 is 3. The third term, half of 3 is going to become 1.5. 1.5 minus 4 is going to be negative 2.5. This is how we did it. All right. Then the 10th term. The 10th term is going to be half times 10 is 5, which is half 10 is 5. 5 minus 4, 5 minus 4 is going to become 1. So the 10th term is 1. Question D. The saying to you in question D, n over 10. So the first three terms, 1 over 10, 2 over 10, 3 over 10. If you would like to simplify this and write 1 over 5, it's going to be fine. You can write 1 over 5 in the second term. The 10th term is going to be 10 over 10, which is 1. So this is the 10th term, 1. The next question here, n squared plus 20. The first three terms, 1 squared, which is 1 plus 20, about 21. 2 squared is 4 plus 20 is 24. 3 squared is 9 plus 20 is 29. Then I have here the 10th term. 10th term, 10 squared is 100 plus 20 is 120. Now question 6. Question 6 says to you, match each sequence, card A to D, with the correct nth term expression with I to IV. Here, I'm going to replace n with 1 to see which term is going to be the first. 1 squared is 1 plus 2 is going to be 3. So if I want to find the first term, I'm going to test it this way. What is the first term going to be in this sequence? Try the first term. 1 squared is 1 plus 2 is 3. So, Mister, definitely it is C. Card C. That's the only card that has 3 in the first term. But here, Mister, 1 plus 1 is 2. The only sequence that has 2 in the first term is D. 1 over 3 is the first term, which is B. 1 cubed is 1. The first term is 1, which is A. The cards show one term from 2 different sequences. The 11th term in the sequence, nth term is n squared minus 33. 120th term in the sequence, nth term is 2/3 multiplied by n plus 7. Without doing any calculations, a conjecture. What is the meaning of conjecture? Like guess. Which card has the smaller value, A or B? Explain why you chose this card. Well, my conjecture and the guess, and I know that this question is a little bit tricky, but my conjecture or my guess would be card B, because linear sequences grow much smaller, much slower than quadratic. I would choose this. I would say card B because linear sequences grow much slower than quadratic. This is a quadratic sequence. It goes bigger in a faster way, much faster way than a linear sequence. That's my guess. Am I right or wrong? It's a conjecture. I might be right, I might be wrong, but the most important thing is that I give a reasonable explanation, an explanation that is correct. I might be wrong at the end that this is bigger or that is smaller, whatever. I just need to give a reasonable explanation. My explanation depends on a fact, actually. What is the fact? That the quadratic sequences grow faster or they get bigger faster than linear sequences. Let's see right now in question B, work out which card has the smaller value. Work it out. Now it's not a conjecture, it's not a guess anymore. It is the actual answer. 11th term in the first card, card A, the 11th is 11 squared minus 33, which means 121 minus 33, which is going to give us what? 121 minus 33. If you minus the 3, is going to give you exactly 118. You minus the 30 is going to give you exactly 88. This is card A. Card B is what? The 120th term. So I need 2/3 of 120, then plus 7. 120 times 2/3, or you can do it 100, you can do 120 times 2, and then you divide by 3. You can do this, or you can do 120 divided by 3, which is 40 times 2, which is 80. 80 plus 7 is going to be 87. So just to multiply a fraction by the whole number or get a fraction of 120, the answer add to it 7 gives you exactly 87. Oh my God. Okay. So my guess, did you choose the correct card? Yes, I chose the correct card. That B is smaller. Yes, I chose the correct card. Decide if each of these sequences is linear, quadratic, or neither. Here I added a 7, then added a 7, then added a 7, add a 7, add a 7. So it is linear. Here add a 3. Not necessary. Here the first differences are the same. That's why we said it's linear. Here, you're going to find that the first difference add 3, then add 6, then huh, add 3, then I added a 6, right? But after the 6, what happened? We added 12. Then what happened? We added 24. Then what happened? We added 48. Or, mister, we're multiplying because actually to find out if it's linear or quadratic, I must find the differences. Don't say, mister, it's times 2, times 2, times 2. Well, okay, but this is not the differences. This is the term-to-term rule. What you're trying to say right now, multiplied by 2 is the term-to-term rule. But to find out if 3, 6, 12, 24 is linear or quadratic, I have to write it this way. Just a second. Here we go. Look at this here. It is 3, 6, 12, 24, 48. So here I added 3, added 6, added 12, added 24. The first differences are the same? No, then definitely non-linear. Let's check, is it quadratic or not? The second difference, add 3. Then here, oh, add 6. Then here, add 12. Is it going to be quadratic? No, yeah, mister, it is neither. Up next, we minus 40. Then we minus 20. Let's do it. 80, 40, 20, 10, then 5. Minus 20, minus 40, minus 20, minus 10, minus 5. Then here we said this is 40. The difference is what? The difference here is 20 or minus 20, whatever. While here is going to become 10, while here is going to become 5, right? So what is happening? The difference between them is what? It's not the same. So it is neither. Good? It is neither. All right, in question B, 4, 6, 10, 4, 6, 10, 16, 24. Added a 2 emister. Then here, added a 4. Then here, added a 6. Here, added an 8. The second difference, add 2. Add 2. Add 2. Okay, so what is happening in here? This is a quadratic sequence. The coming one, minus 1, then minus 2, then minus 3, then minus 4. You're going to find that this is a quadratic sequence as well. Look at this here. Minus 5, minus 4, we said here, 25, 24, 22. Minus 1, sorry. I'm sorry, I was just thinking about another question right now. All right, so here, this is minus 1. 24 becomes minus 2 to become 22. Then I minus 3. Then I minus 4. The second difference, mister, between each one and the other is 1, 1, 1. Okay, so here what do we have? It is quadratic. 32 to 28. What happened to it? Let's go down and see. Mister, we don't need to. I minus here 4. Then 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 I minus here 4. So it is linear. Good? All right. Question 9. Work out the nth term rule for each of these quadratic sequences. 1, 4, 9, 16, 25. Mister, they said it's quadratic, and I see that this is a list of a list of what? Square numbers. So it is n squared, Mister. N squared. Okay. So I see that it is quadratic. N squared. طب try it كده. What if I want to try for the first term? 1 squared is what? Is 1. Oh, it is already 1. Yes, I don't need to add or minus anything. طب try for the second term. 2. 2 squared is 4. Oh, thank you. I don't need to add or minus anything. So it's just n squared. طب what about the other one? B. Mr. Huma, they told me already that it's quadratic, so I don't need to test it and see if the second differences are the same or not. They told me that it's quadratic. So it's n squared. Test it. N squared is what? Try it with 1. N squared, which is 1 squared, is 1. I need 20 more. طب for 2, Mr. For the second term, will it work? Try it. For the second term, 2 squared is 4 plus 20 is 24. Yes, it worked. The next one is also n squared. It is said it's quadratic. طب 1 for the first term, 1 squared is what? Is 1. طب how many do I need until I reach negative 1? Oh, you need to minus 2. طب let's try for the second term. 2 squared is 4. I need to reach 2, so go down 2, so minus 2. N squared minus 2. Try it now. 2 squared is 4, minus 2 is 2. طب for the third term, Mr. 3 squared is 9, minus 2 is 7. So how do I do it? N squared, I tried with the first term. 1 squared is 1. How many more or less do I need to go until I reach negative 1? It is minus 2. Next one here. N squared, they told me that it's quadratic. After n squared, I tried on 1, the first term. 1 squared is what? 1. But I need to reach 8, يبقى plus 7. That's it. Okay. Next. Look at this number sequence 7, 10, 15, 22, 31. Just by looking at the numbers in the sequence, explain how you know that the nth term rule for this sequence cannot be n squared minus 10. Well, just by looking at it, I know that it is wrong because the first term in this will lead to a negative number. Never, it's never going to be 7. The nth term cannot be this because the first term of this must be negative. And the rule and the sequence here is not negative. I didn't calculate anything. All what I'm saying is that the first term must be negative for n squared minus 10. Because I know 1 squared is 1. Minus 10 is going to be negative 9. Definitely is going to be negative, Mister. And it's not negative. So just by looking at it, I know that this is not the nth term for this sequence. Question 11. What's the nth term for each of the following sequences? This is n over 13. Because the first term is 1 over 13, the second is 2 over 13, the third is 3 over 13, and so on. While the other one here is n over 9. 1 over 9, the first term is 1 over 9, the second term 2 over 9, the third term is 3 over 9, which is 1 over 3. They simplified it and said it's going to be 1 over 3. C, it's n over 12. Mister, n over 12, its first term is 1 over 12, okay. Its second term is 2 over 12, mister, not 1 over 6. Yes, but in the simplest form, it will be 1 over 6. The third term, mister, is 3 over 12. Yes, in the simplest form, it will be 1 over 4. So the nth term is n over 12. This is n over 9, and this is n over 13. The cards A, B, and C show one term from the three different sequences, Work out the term for each card. Let's do it. Ninth term in the sequence, nth term is 9 n over 15. Yeah, but so it's going to be 9 over 15. Divided by 3 is going to be what? 3 over 5, right? But here in Mr. 10th term, which is 10 over 16. Simplest form is going to become divided by 2 is 5, divided by 2 is 8. Eighth term, 8 over 14. Simplest form is going to be divided by 2 is going to become 4 over 7. Then now we answered the question A. Sorry, question A. Work out the term for each card. Write your answers to part A in order of size. Okay. Now do you want me to put 3/5, 5/8, 4/7 in order? So how are we supposed to do this? Make the denominators the same. All the denominators, Mr. Yes, all the denominators. You must make them the same. How are we planning to do that? You can find a common denominator. You can just multiply 8 by 7 is 56. We can't Mr. 56. I will turn the 8 into 56, the 7 into 56, but the 5, I cannot turn it into 56. 8 times 5 is 40. I cannot make the 7 into 40. So what are we supposed to do, mister? You're supposed to actually multiply the three of them by each other. 5 times 8 is 40. 40 times 7 is going to give you 280. 280. Okay. But mister, I made them now the same. Again, how did I do that? This, I multiplied 5 by 8, which is 40, by 7. 40 by 7 is 280. I made the denominator the same. What did I multiply this by? The 5, I multiplied it by 7 and by 8, right? So I multiply the 7 and 8. Then I multiply the 3 by 7 and by 8. The 8, I multiplied it by 5 and by 7. So multiply the 5 by 5 and by 7. The 7, I multiplied it by 8 and by 5. So I'm going to multiply the 4 by 8 and by 5 too. Now let's do that. We already have the denominators done for us, 280. We did 8 times 5 times 7 already. Here, I'm going to do 3 times 7, which is 21. Multiplied by 8 is going to give you exactly 168. So 168. Here in the second one, 5 times 5 is 25. So 25 multiplied by 7 is going to give you exactly 150. No, sorry, 175. 175. 4 multiplied by 5 is 20. 20 multiplied by 8, the order doesn't matter. Multiplication, that's why I chose to start with 4 times 5 is going to make it easier. 4 times 5 is 20. 20 times 8 is 160. Now, yeah, mister, it is clear that the third one is the first. Card C is the first. Card C, which is 4 over 7. First. Then I got, after that, card A, which is 3/5. Then I got the last one, card B, which is 5 over 8. Now I put them in order. That was the answer to this. Question 13. Work out the answers. Let me erase this. Work out the answers to the answers to these questions. Show working to support your decisions. The nth term rule for a sequence is n squared plus 34. Is the number 292 a term in this sequence? Is it a term in this sequence? What are we supposed to do? I'm supposed to actually write this n squared plus 34. Can it be 292? You can use the calculator for such a question. It is fine. So I'm going to use what? I'm going to do what? Solve that. I'm going to solve the equation. I'm going to say n squared equals 292 minus 34, which is going to be n squared equals 258. Is there a square root for 258? You're going to find no, there is no square root. Which means what? It is not a term. 292 is not a term in the sequence. How did I know that? I knew that because 292 has no position in this sequence. How n is the position. If it is, for example, 4, then it means 292 is going to be the fourth term. But if it was 16 exactly, then 292 is the 16th term. But Mr. 16 point something, no, it has a decimal. That means it's not, it has no position in this term, in this sequence. 292 is not a term in the sequence. This is how we know if a specific number, a term, if it is a term in a sequence or not. You just solve the equation and you solve for n. Find, is n going to be a whole number or n is going to be a decimal? A whole number, then yes, it is a sequence. It is a term in the sequence. If it is a decimal number at the end, then no, it is not a term in the sequence. Let's look at the coming one. They're saying to n cubed. N cubed equals 5832. Solve for n. N equals cubic root of 5832. If you find that there is an answer to this, I wanted the cubic root of 5832 equals 18 exactly. Whoa. So 5832 is a term in the sequence. It is actually the 18th term. Okay. Next, question 14. Work out an expression for the nth term. All right, here what is happening? I added 1/3, then I added 1/3, then I added 1/3. Mister, it is linear, so it is 1/3 n. Okay, what do we do after that? After that, find term 0. Term 0 is what? I'm going to go back over here. You're going to find that it's positive 8 and 1/3. Yeah, but Mister, it is 1/3 n, because every time I'm adding 1/3, add 1/3, add 1/3, but 1/3 n. So after that, Mister, term 0 is going to be what? Aha, term 0, if I go back, is going to be 8 and 1/3. Question B. I minus 0.3, then minus 0.3, then minus 0.3. Mister, it is negative 0.3 n. Done? No, term 0. Term 0, Mister, is going to be 12.8. Plus 12.8. Here, what is happening? Here, Mister, I added, Mister, I minused. It is getting smaller and smaller and smaller. These are negative numbers that they are not positive numbers to say that it's getting bigger. So I minused. It is getting smaller. By how much? It is 2/4. 2/4 smaller, which means what? Which means a half. But anyway, if you want to write it 2/4, for now, I don't mind it. So you can write, Mister, it is getting smaller. I'm minusing 2/4. Then I minus 2/4 again. Then I minus 2/4 again. So it is negative 2 over 4n, which means negative half n. But Mr. What about term 0? If I go back, what is it going to be in there? Well, if you go back, you're going to find that it was negative 2 3/4. This is the term that is before the first. If you add to it, if you test it and you try to go down to your minus from it 2/4, you're going to find that it goes down to negative 3 1/4. Don't let this confuse you. We're dealing here with negative numbers. So yes, it makes sense that 1/4, 3/4, it is actually getting smaller because we're dealing with negative numbers. It is not 1/4, it's negative 3 1/4. It is not negative, it's not 3 3/4, it's negative 3 3/4. So it's getting smaller, and we found that term 0 is negative 2 3/4. Here we're minusing 3.5, then we minus 3.5 again, then we minus 3.5 again. So it is negative 3.5n. Then what about term 0? The term before the first. It is going to be 3.5, Mr. Positive 3.5. So negative 3.5 plus 3.5. Here in question 15, let me erase this first. The nth term rule for a sequence is n squared plus 2n minus 1. This is how you work out the fifth term in the sequence, and they even explained it to you. Work out the first three terms in the sequence. The first three terms in the sequence. And work out the first three terms in the sequence, work out the 10th term in the sequence as well. Let's do it. First three terms in the sequence, it is actually n squared plus 2n minus 1. First term is going to be what? 1 squared, which is 1, plus 2 times 1, which is 2, minus 1 equals just 2, Mister. That first term. Second term, 2 squared is 4, plus 2 times 2 is 4, minus 1 equals 4 plus 4 is 8, minus 1 is 7, Mister. That's the second term. Third term, 3 squared is 9, plus 2 times 3 is 6, minus 1 equals 15 minus 1 is 14, Mister. 10th term, 10 squared is 100, plus 2 times 10 is 20, minus 1. 120 minus 1 is 119. This is the 10th term. The same thing exactly. You're going to use the nth term rules to work out the first three terms and the 10th term in this exactly the same technique, the same everything that we've done over here. It's just that you're going to multiply. I'm going to work out with you only one of them, because it's going to take so long to do that in the video. I'm going to do the same thing. Actually, not so long, but you don't need me to do each one of them with you. You can find the answers definitely in the answer key. Go and open the PDF for the answer key. Then you can work it out. You can mark your work from there. But for the steps, I'm going to do with you the 10th. So 10 squared is going to be 100, plus 5 times 10 is going to be 50, plus 3, which is going to be 153. This is the 10th term. Here it's 3 multiplied by 100, because now it is not 3 times 10. Don't make this mistake. It's going to be wrong. It's 3 multiplied by 10 squared, which is 3 times 100. It's not 3 times 10, then square it. No way. Only the n is squared. You have 3 times 100 minus 2, which is going to be 300 minus 2, yani 298. Here is 10 squared. You have 2 multiplied by 100, Mister. Minus 3 times 10, 30, plus 10. 2 times 100, Mister, is 200. Minus 30, plus 10. equals 2 minus 30 is going to give you 170. 170 plus 10 is 180. That's it. Thank you so much, everyone, and see you in another video.